Welcome to The Explainer. Today, we're tracing something absolutely foundational, the exact prerequisites for human thriving. We're going to follow this incredible path, starting from the strict physical, geographic limits of our ancient ancestors, all the way to the cutting-edge artificial intelligence and infrastructure we're building right now. It is essentially the story of how we engineered our own optimal environment. Let's get right into it.
Here's our roadmap for today. We'll start with our geographic sweet spot, then look at mapping human knowledge, trace the AI evolution, dive into the generative AI boom, and finally, look at how we're hardwiring our future.
All right, part one, our geographic sweet spot, the physical foundation.
Now, I want you to ask yourself a question. Way back before modern technology, what were the absolute non-negotiable baseline conditions required for a society to survive, expand, and innovate? Because, back then it wasn't about internet speed or power grids, it was entirely about the climate.
Historically, human civilization was completely confined to a shockingly narrow geographic sweet spot. If you look at those green bands across the globe here, they represent a mean annual temperature of just 11 to 15 degrees Celsius. That's, about 52 to 59 degrees Fahrenheit? That tiny, specific window is what allowed for stable agriculture and predictable seasons. We were literally tethered to the weather.
Moving right along to part two, mapping human knowledge. This is where we start building our intellectual environment.
So as we slowly transcended pure physical survival, we actually built a brand new kind of environment, an intellectual one. This map illustrates the blueprint of that flourishing. Long before anyone was writing computer code, early thinkers categorized human knowledge into three main pillars. You've got memory for history, reason for logic and math, and imagination for art. By putting a structure on our intellect, we basically learn how to organize data.
Which leads us perfectly into part three, the AI evolution.
Because once we mapped out our own reasoning, the next logical step was trying to teach machines to do the exact same thing. Officially, this kicks off around 1950 with Alan Turing's groundbreaking paper. And by 1976, we were already hitting some early successes with rule-based systems like Mycin. Now, it definitely wasn't a straight line. Enthusiasm kind of dried up a few times, leading to massive funding droughts that the industry famously calls the AI winters. But researchers pushed through, pivoted to machine learning, and that brings us to today, where deep learning absolutely dominates the 21st century.
Okay, part four, the generative AI boom. This is our new cognitive engine.
We are standing right at the apex of this intellectual environment, and the sheer scale of it is just staggering. Check this out. The global generative AI market, which was sitting at roughly $22 billion recently, is projected to skyrocket to over $324 billion by 2033. I mean, wow, right? That is a massive 40.8% compound annual growth rate. And a huge chunk of that is fueled by cloud storage, which basically lets businesses train these super resource-heavy models without having to build their own massive supercomputers.
Driving that entire $324 billion market are two absolute powerhouse technologies. On one side, you have transformers. Now, they dominate the market today because their self-attention mechanisms efficiently handle vast amounts of data. They're perfect for chatbots and really complex problem solving. But on the other side, you've got diffusion networks, and these are rapidly gaining momentum. They work by progressively removing noise from data to create those hyper-realistic AI images and videos you are seeing literally everywhere online right now.
Which brings us to our final section, hardwiring our future, the physical infrastructure.
Here's the thing, though. All of this incredible cognitive power requires a seriously formidable physical foundation. We aren't just relying on traditional electronics anymore. Look at the intricate pathways of these photonic integrated circuits, or PICs, feeding into those towering data center servers. These new circuits actually use light instead of electricity to enable high-bandwidth, low-power communications. So they are quite literally becoming the highly efficient nervous system for our new global AI brain. And this amazing infrastructure brings that societal flourishing right back down to your everyday life. It's powering the Internet of Things, wearable wellness monitors, telemedicine, autonomous vehicles. But to actually fit into your daily life, this tech has to meet some really strict demands for lower size, weight, and power consumption. The industry actually calls this SWAP. By shrinking these high-powered sensors down to miniaturized chips, we're basically weaving real-time AI into almost everything we touch.
So as we zoom back out to look at the whole picture, we see a species that started out completely confined to a narrow 11-degree temperature band. But now, we've mapped our own intellect, birthed artificial reasoning, and literally woven global networks of light to sustain it all. So I want to leave you with this provocative thought. Moving forward, are the optimum conditions for human flourishing still tied to our earthly origins, or have we actually reached a point where our survival and our thriving are entirely dependent on the artificial superstructures we're creating today? Something to think about. Thanks so much for joining me on this explainer. Keep questioning and keep exploring.